Okay, we're going to take two problems, very similar because they both have two terms. And the first thing you want to do is always take out your GCF. So out of this guy, we don't have a GCF made up with the variables, but we do have a GCF of 4. So we're going to take out our 4, and that's going to leave us with x to the 8th minus 16 y to the 12th. And then you want to focus on, we have two terms left. Anytime you have two terms left, it could be a difference of two squares or a difference of cubes. Well, 16 is a perfect square, it is not a perfect cube. So let's see if we can break it down like a difference of two squares. So it would be opposite signs, and your exponents just have to be even. So divide your exponent by 2, and the first one goes into the first position. Take the square root of your 16, and then divide your 12 by 2. I'm going to squish that in there. And then if I FOIL these back together, combine like terms, and then distribute my 4 back in, I should get back to my original problem. Because if you have factored correctly, the answer, if you multiply it out, will get you back to the original problem. So if I were to multiply this out and I don't get back to here, then I know this is not correct. And it could be that we need to possibly look at, can we factor again? Well, this can't be a difference of squares again because it's a plus sign. But let's look at this guy. Could that be a difference of squares again? Well, let's take a look. Could it factor into opposite signs? Break that guy up, x squared, square root of 4 is 2. And then our y to the 6, we would divide our 6 into a 3. And then this difference of squares factored into this. Now this still needs to be in my final answer. And then that would get me back to my original. All right, now let's look at this guy. All right, GCF first, so we can take out an x cubed, which would leave me x cubed plus 512. This is two terms, but it can't be a difference of squares because it's a sum sign. Let's take our 512 and check it to see if it's a perfect cube. So my calculator, I'm going to press my math button right here, and I'm going to look for my cube root option, which is option 4, and then I'm going to type in my 512, and I got an 8. So the cube root of 512 is 8. Now, this is a perfect cube, so it's going to factor into a binomial and a trinomial. The sign pattern is same, opposite, always a plus. Divide this guy by 3, we get x to the first. Cube root of that was 8, we got that from our calculator. And once we have the binomial, the trinomial comes from the binomial. Square this, multiply these two together, and square this guy. On occasion, this could be a difference of two squares and it might factor again. In this case, it's not. This looks like a perfect square trinomial, but it is not going to be a perfect square trinomial and thus will not factor again.